Okay, so fully homomorphic encryption, or FHE for short. I guess it'd be good to start with a bit of an explanation of what it is, how it works, and I guess also importantly, why does it matter? Why is it such a big deal?
Yeah, so fully homomorphic encryption is a new encryption scheme that allows to compute the data while encrypted. So up to now, we heard a lot about encryption, but it's usually either encryption when data is in transit on or when data is at rest. So storing data or moving data from one point to another. But whenever we need to operate on the data, we have to decrypt the data because no computer knows how to operate on data that is encrypted. The the new thing that the the novelty that FHE is bringing to the table is that now that third state of data, that is when we need to use it, we can maintain the encryption even when using it. And that gives us basically two benefits. One is privacy, right? So I don't care where I am processing the data. For example, today in the cloud environment, I need to trust the cloud provider that it's not going to look at my data. With FHE, I am guaranteed that the cloud provider cannot look at my data because it's encrypted. And the only one that has the key to decrypt it is myself. The other thing is on the security side, if the computer, whether it's mine or in the cloud, is infected, will might be able to steal that data, but basically you still encrypted data, so there's not a lot you can do with that.
Okay, and in terms of some of the main FHE use applications, I guess what will we want to do with data encryption during, as you've explained, computation, and what are the reasons behind that? So what in terms of its use, be good to understand.
So I think that there is over the last probably 10 years, 10, 15 years, we have seen a huge explosion of data and data being collected. So with all the uh, advance of e-commerce, so companies collecting data about users and trying to personalize the offering for those users. And on the way, basically, it was kind of the Wild West, people just collecting whatever they want. And at some point, uh, governments, people started to complain because basically there was too much information out there about whatever every one of us is doing, right? And we need to control that, right? So I think that today that there is no way of processing that data in a private way. There is no way to guarantee what happens with that. Now, once we can guarantee that privacy, so it gives the power to the owner of the data to decide what they want to do. So some examples, let's take, for example, AI, right? AI or Gen AI are based on training those models with a lot of data. Now, that data has an owner, right? So initially, a lot of that data was just scrapping data from the internet, right? But we start to see that uh, the more sophisticated models want to get to more private data or more sensitive data, right? Not just the public data that is available for everybody, right? And there has to be a way that you don't just give access to all your data, but you can somehow rent your data or get the insights of that data without seeing that data. So one of the big benefits of FHE is I can let you run analytics, for example, on my data without you seeing the data. So you will be able to get the information that is inside the data, but you won't get access to my data, right? So a lot of applications where privacy is a big issue. So we are seeing continuing on the AI path A lot of companies that are afraid of enabling AI inside the company because of fear that data will be leaked into the internet, right? So an application like summarizing, let's say, this meeting, right? Transcribing this meeting or summarizing this meeting, that's great. Now, if I need to send this video to a third party, that person will have access to whatever it is that we are discussing. Maybe I don't want them to have access to that. So FHE will allow you to send them the data. They will process it, but they don't have access to the data. So they will be able to encrypt in an encrypted way, transcribe this conversation, send it to me, but they won't see not the video, not the transcription, nothing. So they will learn nothing about whatever it is that we are talking about, but I can use their algorithm for transcribing. I don't need to develop my own algorithm to transcribe, right? That's, of course, that's an example, right? So things in the healthcare world, right? There is more and more tools to help doctors diagnose. So if it's an MRI, reading an MRI or reading an X-ray, right? Companies that can basically use vision technology and pattern recognition to try to see, for example, cancer or any other diseases, right? That today I need to tell them, okay, Jorge, this is Jorge's X-ray, right? Go and do your thing, your diagnosis. Whether they can maintain that privacy and they won't publish that Jorge has A, B, or C, it's up to them, right? There is a factor of trust today because it's between people that yes, everybody will sign that they are not going to disclose anything, right? But it's impossible to prevent it, right? There was, I think it was last year or the previous year, right? Tesla employees with the cameras, right? The cameras, as you know, Tesla's cars are recording all the time. So they are recording also when they are in the garage. Now, people don't realize that basically there is a recording device there and they might do things. They might walk with half clothes or whatever, right? And those videos are uploaded to Tesla, right? And, started as a joke. Someone saw a video, thought it was funny, sent it to someone, and that leaks. So there was no malicious intent, right? But at the end of the day, I assume that the person that was in that video wasn't very happy, right? So that is sometimes it's not necessarily security, right? That's why I'm talking about privacy, and sometimes it's on purpose. Someone's trying to steal and get the data. Sometimes it's not on purpose. It's just it's funny, or I didn't take care of that, and that data might leak just because I didn't take care. So this is a way that you can guarantee the data is encrypted all the time. So only the person that has the key is the one that can see that data.
Okay, so in terms of the emerging risks, I mean, I think you covered the sort of the AI issue, if you like, but I'm thinking things like multi-site cloud computing potentially, and also, I mean, the thing looming on the horizon, no one can quite tell me the date, but I think the conversation I had this morning is about 2029 maybe, but quantum and, post-quantum hacking, etc. So how does FHE, what role does that have in those kind of scenarios, I suppose?
So FHE is part of the family of quantum resistant encryption schemes.
Okay, and in terms of developing FHE's potential, um, what do you think needs to happen? Because I guess there's a lot of industry stakeholders, there's sort of hardware, software, the cloud folks need to work. I mean, can they be trusted, expected to work together? Do we need any sort of standards to help the process? Just your thoughts as to how the community needs to work together, ecosystem, whatever you call it. Yeah.
So So FHE starts, the theory behind FHE started in 2009 by Craig Gentry in Stanford with his paper on how this works, the math behind FHE, right? And we saw in the late 2010s, right, beginning of 2020, several software companies that started to develop FHE and basically software solutions for FHE. The challenge is that FHE is pretty compute intensive, and if you run on a regular computer, it will be very slow, right? And that, of course, prevented the adoption because there is so much that you are willing to pay for this solution, right? Not in terms of price, but if the performance is very, very slow, at some point you said, no, this is not worth it, right? So what Niobium is doing right now is building a dedicated accelerator, a hardware accelerator for FHE. So all the computation of FHE, instead of running that on a regular CPU, on a regular computer, we are building a coprocessor basically to accelerate that. So same as, you don't run graphics on a CPU, you run it on a GPU. AI, it's either a GPU or an AI processor, a tensor processor, right? So I think that the type of computation that is required for FHE is different enough that requires a hardware accelerator. And we are not the only ones. There are other companies doing that. So one of the things that is required is that basically having solutions to accelerate that and bring that computation to the level of the computation that you get on the cloud, right? And that's where we start to see that the mass adoption of those solutions, right? So of course it will start, the early adopters will be companies and sectors that are more concerned with privacy. Maybe some of those are regulated, right? But as you move forward and the price being pretty much the same and performance being very similar, right? You will start to see that it's okay. Should I take the risk that my data can be stolen, right? Or should I move to what we call the encrypted cloud? So think about the same cloud that exists today, but fully encrypted, right? And for that, we are working with cloud providers. We are working with OEMs, with server OEMs. And the idea is to work together with the infrastructure companies to build this, whether you want it in the cloud or you want it on-prem, right? It's up to the end user to decide. But we will be offering both options, and we are working with both OEMs and cloud providers to bring that. At the same time, we founded a consortium of companies doing FHE software, hardware, system to work together, define some standards, define test benches, how to test this, how to define performance, how to, you might have an accelerator from one company on one side with software from another company, define interfaces so all the software will run on any accelerator, and of course any accelerator can run any of the software libraries, right? So that is something that it's also being done. That consortium is called FHE, and it was started a couple months ago, and now getting new members, right? So basically, there is a lot of collaboration in the industry between startup companies, more established companies, cloud providers, OEMs, to bring this to market.
Okay, and I mean, I think I can understand that many organizations seek to benefit from normalizing encryption during computation. I mean, are there any people? I mean, clearly the bad actors don't like anything that makes their job, more difficult. But are there any other sort of group of people that might want to stand in the way of this for maybe understandable reasons? But I suppose, yeah. So who's in favor of it and who might be against it, other than, shall we say, the obvious bad actors?
Um, I don't think that is, at least I'm not aware of anybody that will say openly, no, we don't want encryption, right? I think that there are different techniques. FHE is one of those. So there are people doing other type of things, right? So there might be some competition between different solutions on how to do it, right? But I think that there is kind of a consensus that this is required, and as we move forward, right, and you distribute the ownership of the data, the processing of the data, sharing data, right? Imagine sharing data between competitors, right? So one of the examples is fraud detection, right? If you can share data between all the banks in order to run algorithms to detect fraud, right? That would be great. But that means that I'm sharing my clients with your client, with my competitor competitor bank, right? That's not something that banks are willing to do, right? Now, if it's only to get the insight, understand the patterns, but you don't get access to that data, then it's a different story.
Okay, and in terms of the sort of the future drivers when it comes to FHE adoption, I mean, we've obviously talked about quite a lot of use cases, but are there any other sort of compelling reasons that are going to drive it forwards? And I guess on the other side, flip side, are there any particular barriers that you think are still need to be overcome to before FHE becomes more widely adopted?
Um, I think that it starts, uh, as I would say, start with the privacy. I think that the main driver is privacy and protecting the data. But once it becomes mainstream, uh, it will serve other purposes. And in particular, as you know, there is a lot of attacks where you get access to a computer or get access to a system, and then you move inside that system to find data and basically steal that data. Now, if the data is all the time, it doesn't matter in which state, it's all the time encrypted, it's not that FHE will prevent that attack, because it doesn't, right? The attacker will be able to get access to the system, but what you steal is worthless, right? Because it's another layer on top that now you need to break that encryption, right? So once it becomes mainstream, it's kind of an insurance policy, right? That I have on my cybersecurity, right? But even if they are able to break in, they won't be able to steal my data, right? So it might not be a privacy reason, right? But if for the same price or a little bit more, I can protect also my data, right? That becomes a value add. And you can look, for example, I don't know, 10 years ago, we all browsed the internet, and it was HTTP, right? At some point, we started to see HTTPS. That is a security protocol that recognizes that you are talking to the right website. Now, today, you won't see any single website that doesn't have HTTPS. Why? Because it's pretty much for free. So why not? Right? At the beginning, it was only for specific websites that were willing to pay the extra cost and etc. But then when it became ubiquitous, it was a no-brainer, right? The same here, right? It will start with people that are more conscious about privacy, but at some point, right, once the performance is pretty much the same or similar to the performance in the clear, you will start to see that everywhere, and this is what we call, when we talk about the encrypted cloud, right? So you will have a choice. Okay, should I run on the regular cloud, or should I run in the encrypted cloud? Should I take the risk or not?
Okay, and in terms of Niobium, I mean, you've explained what it is Niobium does, but I guess more generally, what do you see as the company's role in terms of helping to develop? You've obviously got some technology, but are you also sort of out there trying to promote the general idea of FHE to people, or are you very much focused on your sort of technology space for now? What are you doing as a company?
So we are doing both, right? So of course we are internally developing our accelerator, right? But at the same time, we are working with the community, and I think that the community has been growing over the last couple of years, whether it's software, whether it's hardware. I think we all understand that right now the pie is small, right? So there's no point in fighting between us, right? There's nothing to fight for, right? So we collaborate, we work together. We started this consortium, FHE, to work together, promote the technology, and enlarge that pie, right? Bring the awareness of FHE to the world. And eventually, once it's big enough, we will have time to fight it for who gets the biggest piece.
So I suppose just in finishing for the end users, I guess a good starting point is to educate themselves as to what it is, as you've explained, what it can do. And is there likely to be a tipping point momentum wise? I mean, is it this quantum, which seems to be, it will change the whole rules around security, encryption keys, all that kind of stuff. Do you think the likely tipping point is something going to happen sooner than that? Just your thoughts, I suppose, as to what end users need to be aware of and prepared for when it comes to FHE into the future.
Um, so I think that it will happen before the quantum computing, and I think that as FHE is also quantum resistant, so it's just on the way too, right? So you don't need to change all the encryption schemes to say, okay, let's use also FHE, right? For each for each state. So when you have data, the storage, the movement of data, or processing, you will probably use different encryption methods just because of the benefits of each one of the states, right? So using FHE for data in use doesn't require you to change the other encryption method that you use to quantum resistant. You can do it, or you can do it later, right? So I think that will happen in parallel. FHE is the first technology to allow this processing of data while encrypted. Right now, there are other ways of doing that, but it's not an encryption. Is basically I can put it inside a box, protect that box, but inside that box is everything is in the clear, right? So the only way of really encrypting data and processing data is using FHE, right? And I think that as we make it faster, right, and bring it to the level of performance of regular computing, we'll start to see the adoption, right? Again, starting from industries where they are regulated or the privacy is very important, right? So you can think of finance, healthcare, definitely government, and then moving into more of general purpose, right? And part of the defense of a company to protect the data.
And maybe just one final question. I mean, you've mentioned there obviously the essentially different encryption for data at rest, data in transit, and data being processed. I guess my simple mind would say one protocol that meant you didn't have to use different encryption methods for different states of the data, shall we say, would make sense. Is that is that a nonsense for understandable reasons, or is that the sort of holy grail that might eventually come about, or are there, good reasons as to why we have different encryption for the data in different states?
Um, I think you will start to see those combinations, right? If you have data stored that you are taking it from the storage to process and put it back in the storage, right? So there are some of those cases that you can think, okay, maybe I don't need to go through all the different encryption schemes, right? I can just use one and do everything. Now, if I'm planning to keep data in storage just as a backup, for example, probably, for example, FHE is not the most efficient way of doing that, right? It will probably take too much space, right? Each one of the encryption schemes is optimized for the specific function, right? Now, again, if in a short period of time, I'm going to go through the different states, you will start to see encryptions going into like, okay, maybe I just encrypt FHE, transmit, process, transmit, store. And only at the end, when I store, I change the encryption. Now, it's up to us as the technology vendors to take care of that, right? I don't expect the end user to have to deal with that, right? Same as they don't deal with that today, right? It should be just, okay, for the end user, it's always encrypted, right? And all the complexity of translating from one encryption scheme to another is up to the technology vendors to figure that out and make it simple.
Okay, it's been fascinating conversation, fascinating topic, and as I say, I just talked to someone earlier today about the sort of quantum and post-quantum world. So it's interesting to have then talk about FHE, which is not unrelated to that. But really appreciate the time you've given me and the insights. So thank you very much indeed for your time. Thank you.
Thank you. Thank you very much.